As we have studied in laminar flow and turbulent flow, when a fluid is flowing from one end of the pipe to the other end of the pipe, during the flow of the fluid, what happens is there is some amount of head loss. That head loss is called as fluid friction. Let us study what are the major causes of fluid friction in a pipe. Fluid friction. Let's study what is a fluid friction. Now, what is exactly fluid friction? For that, we'll consider a small pipe having diameter d. So there is a pipe. Let us define its dimensions. So this is the diameter d and this is the length of that entire pipe. At the initial part, this is section 1 and at the final part this is section 2. During this it is flowing from section 1 to section 2. So here on section 1 there is some pressure P1 and at section 2 there is some pressure P2. Now we all know if P1 is greater than P2 then the fluid will flow from section 1 to section 2. But during this flow of pipe from section 1 to section 2, if we consider an intermediate pressure that is P3 as well as intermediate pressure P4, we can come to a conclusion that the largest pressure will be at section 1, so that is P1, then it will be at section 3, let us consider this as section 3 and this as section 4. So over here this is P3, then we'll have P4, then we'll have P2. So the greatest pressure is at section 1. As we gradually go ahead, the pressure decreases. Now why there is decrease in pressure? Because of the fluid friction. Now the fluid friction is the friction offered by the surface of the solid on the flow of the fluid. So that is called as what? Fluid friction. So to demonstrate this fluid friction, a scientist has given a formula for that. That is called as Darcy's equation. Now let us see what is Darcy's equation. Now, for Darcy's equation, head loss due to friction is given as FLV square upon 2GD. This is the formula for Darcy's equation. Now, let us understand this equation first. To understand this, we'll demonstrate another pipe having a section 1 and section 2. The pressure over here is P1 and the pressure over here is P2. Now, during the flow of fluid from section 1 to section 2, it has to overcome some amount of frictional force. So, there is some energy lost in overcoming the frictional force. Now, over here, there is some energy lost in overcoming frictional resistance and overcoming frictional resistance. So the energy lost in overcoming frictional resistance is calculated in terms of head loss. Now what exactly is a head loss? Let us see this. Now head loss is defined as, or head loss is defined as energy per unit weight. So the energy lost per unit weight is called as head loss, and which is given by Darcy's formula, that is HL is equals to FLV square upon 2GD. So this is actually the loss for a fluid which is traveling from section 1 to section 2. During this, it will have the head loss over that entire length of the pipe. Now, since if we have a pipe and the head loss at section 1 will be minimum and at section 2 will be maximum. During this, the head loss due to friction depends upon the length of the pipe, velocity of the pipe and diameter of the pipe, and another quantity that is called as the roughness of the pipe. Now, how rougher the pipe is on its edges, the degree of roughness on these edges is defined as this F. This is called as friction factor. So let us write down those things. That is the head loss depends upon A. First is length, second is velocity, third is diameter, and the fourth is friction factor. Now, this is also called as major loss in the pipe because the pipe, if it is a very large, so this loss is not only between section 1 and 2, it will be towards the end of the pipe. If the diameter of the pipe decreases, then also there will be few losses. Let us study when there is decrease in diameter or increase in diameter. Now, for now, we have studied what is called as a major loss. Major loss, that is HL is equals to FLV square upon 2GD. Now, this will be in every pipe possible. If the pipe is very small, about of an order of 10 raised to minus 3 millimeters or meters, that is approximately 1 millimeter pipe diameter length, then the minor losses are greater than the major losses. But for a very long pipe of length L, major losses are very large. So in consideration, we'll always consider the major losses in the pipe. In engineering applications also, major losses are taken into consideration. Now, we have seen what is major loss. Let us study what are minor losses in the pipe. Now, before defining the minor loss, let us see what was major loss. Major loss in a pipe is due to the length of that entire pipe, roughness, velocity and the diameter of the pipe. So there will be decrease in pressure at the end of the pipe. That decrease in pressure is due to overcoming frictional force. So that depends upon the length. Minor loss in the pipe will depend upon flow pattern in the pipe. Now, what do you mean by flow pattern? Let us understand what is flow pattern. Now, flow pattern means it will go from laminar to transient to a turbulent flow. So, if a fluid is flowing with a laminar flow and suddenly due to decrease of diameter or influx of a fluid from any other pipe, there is some change in the flow pattern. That means it changes from a laminar flow to transient flow, or from transient flow to turbulent flow, or from turbulent flow to transient flow, or from transient flow to laminar flow. This is called as what? A change. So this is called as change in the flow pattern of the pipe. That means it is going from laminar to transient, transient to turbulent, and it is changing its flow. Now, the first kind of minor losses which we are going to study, that is called as enlargement loss. Now let us study what is enlargement loss. Enlargement loss will be a loss there is where there is increase in diameter of the pipe. So let us consider a pipe having diameter d1. So this is a pipe having diameter d1, and suddenly the diameter of pipe has increased. So at section 1, let us consider the diameter as d1, and at section 2, the diameter is d2, and the velocity at section 1 will consider as v1, and while leaving it will have velocity v2. So now the enlargement loss, that is He, will be given as v1 minus v2 the whole square by 2g. So this is the head loss due to sudden increase in diameter of the pipe. So this is given by a loss called as enlargement loss. This will be between the two pipes when there is sudden increase in the diameter. So one of the loss we have seen what is enlargement loss. The next loss which we are going to consider is contraction loss, which is opposite to what is enlargement loss. So let us write down. So let us draw a pipe which is having a very large diameter initially, and then it has decreased to a smaller diameter. So during this there will be a loss called as sudden contraction loss. So we'll consider a pipe having a section 1 diameter as a d1 suddenly contracted and the diameter of pipe is now d2. Now during this we'll consider the velocity over here is v1, here the velocity as v2. Now so when there is sudden contraction, then over here the head loss due to contraction, h of contraction, will be given as equals to 1 upon cc minus 1 the whole square into v contraction square by 2g. Now let us understand all the terms in this. Now what do you mean by value of cc? This is called as the coefficient of contraction, the degree by which the diameter has reduced from a larger diameter to a lower diameter, then this value is called as coefficient of contraction. So now we'll write down this as coefficient of contraction. Now if the value of coefficient of contraction isn't given in the problem, then we consider that as HC, that is head loss due to contraction, is equals to, that is 0.5 into Vc square by 2g. Now, what is Vc square? That is the final velocity after contraction. So we can write this as h of contraction is equals to 0.5 v2 square by 2g. It is the final velocity after the contraction of the pipe, and the loss is called as contraction loss. Next loss we'll see, that is loss due to entry and loss due to exit. Next loss we'll consider, that is head loss due to entry or loss due to entry. Now, how will you define a loss due to entry? Now, this is where a pipe is connected to a reservoir. So, from a reservoir, the flow of fluid goes from the reservoir to the pipe. So, over here, supposingly, we consider a huge reservoir, and this reservoir contains a fluid which is connected to a horizontal pipe. So initially the level of water in the reservoir is here, and over here there is some amount of gate which will open, and then the water will start to flow in this pipe and it will drop down. Now during this, there is a sudden change in the flow pattern of the pipe. Initially in the reservoir, when it was at rest, the fluid was static. Once we open the gate, due to this, there is some head difference between these two ends. Now during this, what happens is the fluid starts to flow from a static condition to a dynamic condition. So during this, there is change in the flow pattern of the pipe. During that, there is a loss called as entry loss. So H entry is given by 0.5 into v square by 2g. Now, this is the entry velocity, so we'll consider this is ve square. Hence, over here also we'll have entry velocity. Entry velocity means once it has come inside the pipe, the velocity of that fluid once it has entered the pipe, that is called as entry velocity. Now, this fluid will flow and then it will come to a part at exit. So now this over here will have velocity at exit. Now over here you can see the velocity of entry won't be equals to velocity of exit, because first of all over here there is, it overcomes some amount of frictional loss in this entire part. So during this there is some decrease in velocity. That friction loss between that entire pipe is the friction loss due to major losses. That is friction loss to overcome, or head loss to overcome the friction in that entire pipe. So during this part will be called as the exit velocity. So now over here we have the next loss, that is head loss due to exit. So H exit is equals to V exit velocity square by 2g. So this is exit velocity. This will be entry velocity. During the exit velocity, there will be some change in the flow pattern of that. And hence, if there is some change in the flow pattern, there is some head loss over there. That head loss is called as exit loss. And while coming inside the pipe, it will be called as the entry loss. Next loss we'll study, that is head loss due to fitting. Next loss we'll study, that will be head loss due to fitting and or head loss due to bends. So now let us study. So let us study what is head loss due to fitting. So supposingly there is a very long pipe. We'll consider this as pipe A. This has to be connected to another pipe, to pipe B. So to connect this pipe over here, we'll require something called as a fitting, which connects the both pipes similar to a coupling. So over here, what happens is this will close this entire pipe, and when it is traveling from, supposingly this is section 1 to section 2 in pipe 2, what happens is it will have some decrease in the velocity or change in the flow pattern, because the fitting of that entire pipe will obstruct the flow. So hence over here, head loss due to fitting is given as K into V square by 2G. Now this will be the velocity of exit once it has exited the fitting. Similarly, if there is a pipe over here and there is another pipe which is at some angle and they are connected by a bend, now during this there will be some head loss due to bend. So the fluid is flowing in this direction, so head loss due to bend is given as K into V square by 2G. So this is the exit velocity of bend and the exit velocity of the fitting. So over here we'll write this as VB and we'll consider this as VB, considering this as pipe B and this is pipe A. Now what is K over there? That K is called as, in both cases will be called as coefficient of bend or coefficient of fitting. Generally, the values of K are directly given in the problem so that we can find out those. So, I hope you have understood what are the types of losses. Let us summarize that into one part. So, over here, first is one of the main thing that is called as major loss. Now, major loss is a loss due to friction, that is FLV square upon 2GD. Then we have types of minor losses. Minor losses. First is enlargement loss. Enlargement loss, that is H enlargement will be equals to V1 minus V2 the whole square upon 2G. Next loss which we studied, that is head loss due to contraction. Now mind you, this enlargement and contraction both are sudden, they are not gradual. So contraction loss will be equals to HC is equals to V contraction square by 2G into 1 upon Cc minus 1 the whole square. If value of Cc isn't given to you, then we have to consider contraction loss as 0.5 Vc square by 2G. The next loss which we have studied, that is entry loss. So that is entry loss. So the loss due to entry, that means from a reservoir, the fluid is flowing from a reservoir into a pipe. So during this there is some change in the flow pattern, that will be given as H entry will be given as 0.5 V entry square by 2G. And last two losses, they are, first is that is exit loss. So H exit loss, which we have seen, that is V exit square by 2G. And the last minor loss, which is that is loss due to head loss due to fitting and bends. Now that is given as fitting or bend will be given as K into V B upon 2G, VB square by 2G. Now this is head loss due to fitting and bend. I hope you have understood what are different types of losses, that is major losses and minor losses. We'll use this all formulas of major loss and minor loss for solving problems on compound pipe. Thank you.